For part A, we just need to find a single counterexample where we have an odd number greater than 1 such that m squared plus 4 is not prime. So we can just maybe try some out. So if we tried, we can do some in our head to start with. So 3 could be an odd number greater than 1, but 3 squared is 9 plus 4 is 13, so that one's not going to work. 5 gives 25 plus 4 is 29, that is prime. 7, 49 plus 4 is 53, that is actually prime. But how about 9? So if m is 9, then m squared plus 4 is equal to 9 squared, which is 81, plus 4, which is 85. And this is divisible by 5. So it's not prime. There we have it, that's enough for our counterexample. Of course, there's other possible counterexamples, that's just the smallest possible odd number. In part B, we're asked to consider separately when n is odd and when n is even to prove that this statement is true. N as a positive integer implies n squared plus 1 is not a multiple of 4. So case 1 is going to be when n is even. And when n is even, we can write it as a multiple of 2, so 2p. And then I can work out, so I've got my positive integer, I can work out what n squared plus 1 is. It's going to be 2p squared plus 1, which is 4p squared plus 1, which is, because this is a multiple of 4, this is not. This is 1 more than a multiple of 4. I could say therefore it's not divisible by 4, but it seems obvious. There's going to be a remainder of 1 when you divide by 4. Case 2, n is going to be odd. And so it can be written as 2p, a multiple of 2, plus 1. And then it's the same thing again. N squared plus 1, this time is going to be 2p plus 1 squared plus 1. Multiply out this double bracket. That gives me 4p squared plus 4n plus 1 plus 1, which is 4. Sorry, I think I just made a mistake. That should have been 4p squared plus 4p. I can factorize out the 4. And write it like this. And this is 2 more than a multiple of 4. So in both cases, we don't have a multiple of 4. I think that's it. We don't need to say any more. You can say QED, you've demonstrated it, quod erat demonstratum, or proof complete. That's all we need to do.